All right, what's up, everybody? We're going to be picking up here at question 21. Hopefully we won't be interrupted too much here. But this is a polynomial long division problem. X plus 1, negative 3x cubed, minus 2x squared, minus 7x, minus 8. Now, one thing to check on these is just to make sure you have all the terms. If there's something missing, like an x squared or x or whatever, make sure it counts down. So 3, 2, 1, and then no x's at all in that last one, okay? So just double check that before, when you're setting up. And if you're missing something, put a 0, like 0x squared in there. All right, so the goal in this one, make x look like negative 3x cubed. So we need to do, oops, I usually line it up over here so it matches. Negative 3x squared times that would match. So this would be negative 3x cubed. And then plus 1, so this minus 3x squared, like that. Put some parentheses on it and get ready to subtract. Now, when you subtract, you need to SMATO. Boom, boom, boom. Now you can just look at each term, cancel them out, and then negative 2 and positive 3 is just 1x squared. So this is bring down the other term, minus 7x. Try to keep things lined up. Notice how all my x squareds are in a row, or in a column together. All right, so let's make, how do we make x look like x squared? That's just plus x. And so x times x is x squared. X times 1 is x. Oops. There we go. And again, get ready to SMATO. So you're going to subtract the entire thing, which means we SMATO and boom, boom, add the opposites. These terms cancel, bam, bam, and then I get 7, and then negative 1, that's negative 8. And bring down negative 8 here, and this should be pretty simple. We'll just multiply, see, x times negative 8. And if I do that, this is negative 8x and negative 8. And if I subtract it, because these are identical, you subtract them, you get 0. Okay, so you could SMATO and do all that stuff, but you get 0. In other words, there's 0 remainder, so it divides in evenly. And this is your solution right here at the top. Good stuff. It says graph this thing by making a table of values. It's going to be a linear kind of a thing, so we could just make a quick table. And just pick some x's and y's. I might do negative 2, 0, 2. That'll probably give us enough to go on. And so as you plug those in, let's see, if I put a negative 2 in here, that would be negative 3 times negative 3. This would be 6. I should probably write this out over here somewhere. Just going to try to do it all in one little spot here. This is negative 2y plus 3 is greater than negative 3 times negative 2. So just solving that and just work that out. This would be, let's see, this would be 6 and we'll subtract 3. So this would be, subtract 3 from both sides. So this is positive 3, negative 2y, divide, and this is, for the value 2, it is, divide that as 3 over negative 2. And I'm really just looking for the boundary line, so you can just put equals for now, just because I want to graph the boundary line, then I'll determine which side it needs to be on. All right, so 3 over negative 2, that works. All right, now let me move everything down a little bit so we have more space. 0, this would be negative 2y plus 3. We'll do equals for now. Minus 3 times 0, well, that's just 0. So negative 2y plus 3 equals 0. Subtract 3. And divide by negative 2. This is, so y is 2/3. Let me make this 3 halves. Okay. And these are just like creating points for you. These are not great points. I should have picked something like divisible by 3 or something so it would work out more cleanly. But we deal with it, all right? And let's go with 2. Negative 2y plus 3 equals 3 times 2. This is 6. And, negative 6. And we'll subtract 3. This is negative 9 equals negative 2y. Divide by negative 2, and y equals 9 over 2, which is 4.5. Yeah, 4.5. I might change all these to decimals just so they're easier to graph. 3 halves is 1.5, and negative 1.5. So let's go graph those, make sure they're in a line, and hopefully I didn't make any mistakes. An easier way maybe would have been to solve for y first, and then get your values. You could even steal them from your calculator at that point. Probably save you a little bit of work. So negative 2 is negative 1.5, so that's right here. And 0, the y-intercept is at 1.5. That's here. So let's just make sure they're in a straight line. And the other one is 4.5. So this is at 2, 4.5. And I think they're actually in a straight line. I think we did it right. All right. And I'll just start at one of the points, go through the others, and extend through like that. All right, this is my boundary line. Now, because of this right here, this should be a dotted line, not a solid line, so let's change that. Let's go to dotted. Dashed. All right, so again, cut through. And now the question is, which side do we shade? Okay, great point to use is 0, 0, so put 0, 0 in there. And just try 0, 0 and see what happens. So let's try it. If I put 0 in for x, it would make this whole thing 0 right here. If I put 0 in for y, it makes this whole thing 0 right here. So these are pretty much gone. And so, well, this has to be 0 still. So 3 is greater than 0. Is that true? Yes. So this point 0, 0 is part of the solution. So just shade that side that 0, 0 is on. Okay. Good. So fun. This is a lot easier than you think. Just saying these two matrices are equal. Okay, and I apologize for the notation here. These are, for whatever reason, the computer does not understand what this is doing. But these are just matrices. And if two matrices are equal, each element in that matrix is equal to the other. So, in other words, this is equal to this. Okay, so we're just going to unlock these one at a time. First of all, z is equal to negative 8 because they're in the same position. So z equals negative 8. Even easier, y is 15. That's easy. Okay, now we just have to figure out x somehow. So let's use one of the formulas that has x in them. Let's do this one. X plus z equals negative 3. Or you could use the other one. Doesn't matter. Yeah, but you know z is negative 8. So we'll add 8, and I get 5. Okay. So, not too bad. These aren't supposed to be too hard. All right, centripetal acceleration. All right. What kind of variation is this? Okay, so it is, okay, it's inversely proportional to the radius of the circle. It is proportional to the square of the velocity. So let's see, the acceleration, a sub c, equals, and it's because it's a variation, we'll say k. Okay, so there's our constant of variation. And then it's proportional to the square of the velocity. So v squared goes on top. Inversely proportional, that tells you it's in the bottom over r like that. And then when you have top, like regular variation, direct variation, and inverse variation, we call that joint variation. Okay? So that's joint variation. All right, let's do a quick Cramer's rule. Ooh, Cramer's rule. Who likes that? All right, here we go. So just set up some determinant things. So the x value and the y value. Oops, let's make a little more space. Just remember to set these up like this, and then put all your numbers in. What do you mean? Let me make even more room here. Sorry. Just throw all your numbers in there for your coefficients. So this would be 20, 18, 10, 9. 20, 18, 10, wasn't very good, 18, 9, 20, 18, 10, 9, 20, 18, 10, 9. Now once you've set all those up, now you're going to replace a couple of these things. So let's do that. So this is to find the x. So we're going to take the x column out and replace it with the answer column here. So this is negative 132 and negative 66 goes there. And then on the other one, because you want to find y, take the y column out and put answers. Negative 132 and negative 66. Okay? Now, let's just find some determinants. Gonna go down and back. And these two will be the same. And then these two will be a little different, but pretty easy. So let's do it. On the bottom, this is 20 times 9. And I'll just punch that out on the calculator here. So 20 times 9, 180, minus, and then 180 to, well, this is denominator of 0. So once you get denominator 0, you know you have a problem, right? And so now let's look at the problem and see if they're the same line or different lines. Are they multiples of each other? This is double this. This is double this. These are doubles of each other. And negative 66 is double that one. So these are the same line. So as soon as I got to that 0 on the bottom, I actually can stop. This is infinite solutions. Okay? Infinite solutions. Okay? And I think that would be verified here as well. Yeah, 132, negative 132. I'm just going to do the top real quick to show you what it looks like when you get the infinite solutions. Negative 132 times 9, okay, is negative 1188, and 18 times negative 66 also is 1180. So you get 0 for this determinant too. So because of this, and I think it works out there as well, because of that, you know you have infinite solutions, the same line. So just keep that in mind. All right, simplify, identify excluded values. I was going to say, I don't see any excluded values here. So 0.040 times 19.2 times, so that thing closed on me. Hopefully we're still recording. PDF viewer decided to update right on that, right on cue, right? Get back here. Let's see if it saved where we were. I apologize for that. Anyway, so times 7.5, and that's 5.76 if they didn't tell you right around. Yeah, that's a little strange. But anyway, 5.76 or 5.8, and this would be feet cubed. Okay. All right. Good deal. 5.76. All right. It says simplify and look for excluded values. Is there anything that the bottom cannot be? So the first thing I like to do is factor. Okay, so let's take out on the top. We'll do negative 6, x minus 1, just like that. False. X plus 1. There we go. And then the bottom, I'll do 9 and then it'll be 1 plus x, but I'm going to flip it 1x plus 1 just so I can see how it's simplified. Now, before you go too much further, before you cancel these out, which you're about to do, just set the bottom equal to 0. Pretend it's 0, and that would be minus 1, so x equals negative 1. So x is not allowed to equal negative 1. So just keep that in mind. That's your excluded value. And then just reduce this fraction. This would be negative 2/3. Done. Ooh. All right, well, we did the cube root of 216 in the earlier problem, didn't we? Yeah, we did. And I think you could even probably do that. Well, you don't know how to do cube root, never mind. So 216, we'll do cube root. Oh, we did a cube root of negative 216. So 6 to the 3rd power is 216. So this is just 6. So negative 17 times 6 plus 7 times 6 minus 8 times 6 minus 7 times 6. So this is just simple order of operations kind of stuff. All right. So pull that all together and you get let's see, did I miss something? Oh, I did screw up something. That's my fault, guys. I almost fell for it here. These right here are square roots, not cube roots. Notice how they're different? So this just stays. Let's see if we can simplify these guys. So let's delete that. All right, so we'll do this part first. 17 times 6. All right, so this all comes out to negative 60. And then let's work this out. This is 216. But I'm doing square root this time. So this is 216. And the square root of 216 is not pretty. So I get, kind of like we did earlier, we could do 3 times 72, 36 times 2, 6 times 6, and 2 times 3, 2 times 3, and there's all your fruit. Okay? Now, once you have all your fruit, we can put it in the bomb shelter. And I'll just do 1 for both of these because they're the same number. And this would be 2, 2, 2, 3, 3, 3. I think that's all. All right. So now let's circle the ones that are, this is a bomb shelter of 2, so I only need 2 pairs to hop out. So this is a 2 gets out, and this 3, and a 3 hops out. All right. But there's still a 2 and 3 locked in here, so this whole thing becomes 6 rad 6, like that. Okay, so 6 rad 6. So each of these, this is minus 8 times 6 rad 6, and minus 7 times 6 rad 6. Okay? And when you work all that out, this is minus, this would be 90 rad 6. Okay? Let's keep it going. You need the conjugate here to knock out your terms here. So this would be equal to 5 over, well, let me do my conjugates first. This would be negative 7 minus rad 2, negative 7 minus rad 2. You're going to FOIL these terms there on the bottom, but you don't have to worry about the O and the I because you picked a conjugate, they're just going to cancel out. So first and last, this would be 49, and this would be minus 2, so this is going to be 47 when we're done. And the top was negative 35 minus 5 rad 2, and so this is just negative 35 minus 5 rad 2 all over 47. Okay, hopefully that clicks for you. Solve by substitution. Substitution says when you get one letter all by itself like this, notice how y is equal to all this. That means wherever you saw y in the other equation, let's just switch this box with this box. That's what substitution means. So 6 times 4x minus 7 equals 24 24x minus 42. This will be 24x minus 42 equals 24x minus 42. And now notice how if I subtracted these things, you would get 0 equals 0. And when you get 0 equals 0, that's infinite solutions. So it's basically anything on that line. And so this, it's any x and y that works in that line because they're the exact same line. So all your solutions, when you get 0 equals 0, just push them together and you get infinite solutions. And if you want to describe it, it's not every solution in the whole wide world, but it's every solution that happens to be on that double line. So you could just, I think in the answer key, let's see, they put, set of all x and y such that they fit on that line. So just, that's a more descriptive answer, but infinite solutions should suffice. All right. Continuous, discontinuous, all those things. There is, okay, so if you see this little circle here, it's kind of hard to see, but there's a hole. It's called a hole. And because of that hole there, we say it's a discontinuous. It passes the vertical line test. So it is, okay, it is a function. So it is a discontinuous, and you say it has a point of discontinuity at 7. Because that's right there. Okay, good stuff. Let's keep it rolling. Number 32, determine the vertex and axis of symmetry. Okay, vertex is really easy. Vertex is, you pull it from here, but remember x, it's always x minus h, so the x is opposite. So it's really negative 9 was my h value, and then negative 10 was my k value. So this is h, this is k. This is the vertex, okay? Now the vertex of my parabola is at the center of that. This is the dot right here. The line, the vertical line that goes through that is my axis of symmetry. So AOS is always this, actually it's a negative, it's upside down parabola, but it doesn't matter. It's always the value of x right there. So it's just going to be, remember every vertical line is x equals something. Well, x equals negative 9. This is the AOS. Axis of symmetry. Fun. All right, let's keep it rolling. All right. So this one is an encoded matrix thing, and you're just going to plug these two matrices in. If you remember, basically, in theory, someone took some random matrix, we'll call it A, then they multiplied it by the matrix E, we'll call the encoding matrix, and it gave me this matrix here, I'll call it B. So, how do I get from B back to A? Well, if I multiply by the encoding matrix, if I multiply by the de-encoding matrix, I'll get that. So what you have to do is keep it in the same order. So you have to do this matrix B here first, times the inverse of E will undo everything E did, okay? So this will give you your answer. Now, when you plug that in, so put this one in for B in your calculator, or A, or whatever you want, and then put this one in for another one, and you can pick any of those names you want, but you're going to do this one first, okay, and then do this one second, and then do the little inverse sign on it, and then hit enter, and you'll get a matrix, and it will be, and I'll just save you the time here, 7, 4, 5, 15, 7, 19, and 15, 21, 19, and if you turn those into letters, you're going to go down column by column. So this is 7, 15, 15, so that's G, O, O, and then 4 is D, and then G, U, E, S, F. Good guess. All right. Good guess, everybody. So if you need some more help on that, but essentially you plug this one into your calculator, plug the second one in, and then just do the first matrix times the inverse of the encoding matrix. Okay, so if you put them in as A and B, that's fine. Just do A and B inverse. That was from your investigation. That's why we do it. All right. It says divide, then evaluate. Remember, dividing is the same thing as multiplying by the reciprocal. So this is negative 18 to the x to the 5th over 14x to the 3rd y times, now flip it, 14x cubed y cubed over 9x cubed. Now let's look to cancel the mess out of this thing. First thing I'm going to do is connect the lines. Now I'll cancel the 14s, x cubes cancel here, 9 and 18 cancel, leaving a negative 2 up here. Don't forget that negative, he's important. And then this will be 5 and 3 down here, and 1 here. All right, so one of these y's will cancel one of these y's, so this will be y squared now, not y cubed. And then this one will cancel, and leaving x squared here. So this whole big mess turned into negative 2. Denominators are gone. Negative 2x squared and y squared. Okay, so negative 2x squared, y squared, and you plug in. So 1, that's just going to be 1, so this is negative 2, and then 4 squared, that's 16, and this is 32. Negative 32, rather. All right. All right, good stuff. Graph, slope intercept, this is going to be easier. So let's add 5 to both sides, so 6y equals 5x, add 5x, minus 12. And we'll divide everything by 6. And y equals 5/6 x minus 2. Now, let's translate this to the graph. So this is going to be starting at 2, rise over run. So rise 5, 2, 2, 2, 2, 2, 2, 2. Run 6, 1, 2, 3, 4, 5, 6. Bam. Okay. Also, drop 5, 1, 2, 3, 4, 5, and run 6. Now, once you get your points in a line, let's connect the dots. And there she goes. Good stuff. Good work, everybody. Oh no, get back here. All right, let's finish this up here. We got this. We're gonna multiply the tops, and we need to get common denominators, so I'm going to do an x. I'm going to do 8 plus x and 8 plus x here and here. And I'll do 8 minus x and 8 minus x here. Now, these are still going to be a difference of squares when we're done. So the o's and the i's will cancel because one's plus and one's minus. So on the top we get, this is 2 times 8 is 16 plus 2x over, and then the bottom becomes 64 minus x squared. And it's going to be minus, and then this would be 48 minus 6x all over 64 minus x squared. Now, because they have the same denominator, we can put them into one thing. So this is 16 plus 2x minus. Now, look how it's minus. It's subtracting this whole thing. So I've got to change the signs to kind of see this properly. But this is minus 48 minus 6x. So just be really careful here. Okay? All over 64 minus x squared. Okay? What does this mean? Well, it means we're going to SMAUTO this, because you would have probably missed this one if you're not careful. Okay, people that are not careful will make a mistake here. Okay, now this is 48 and 16. Let's see. Let's do, what do we want to do here? Let's do 16, yeah, let's do 16 and 48 is, that's negative 32. And 2x, and so this is plus 8x all over 64 minus x squared. Now, if we're going to write things in the proper term, we'll kind of flip the order here. So this would be 8x minus 32 over, and then I'll just do negative x squared plus 64. I can factor out that negative on the bottom and then make it a little bit prettier maybe, but these are all equivalent expressions. So I could do negative, and we could factor the top too if we wanted to, but you're kind of good here. I think the answer key gives 8, factors out the 8x minus 4 like this, and in the bottom they pull out that negative, put out front, and they do x squared minus 64. And there you have it. All right, let's divide this by 6x. This is not a polynomial long division per se, because it's just one term. So you can just divide. I mean, you could set it up like, we could set it up like a polynomial long division. But essentially 18x cubed. You know what, let's not do it. I'm not gonna do polynomial long division. Watch this. Because it's just one term, I'll just do 6x. If you divide the whole thing by 6x, it's the same as dividing each part by 6x. Does that make sense? And let's see if I can make it work this way. If not, I'll go back and do long division. So 3x squared plus, and then 6x goes into 48 8 times, so 8x, and then 6x goes into 52. That doesn't go evenly. I knew I was going to run into a problem. Let's drop back and punt. I wondered if I was going to have to do that. It's probably the right thing to do is polynomial long division. So just because you never know how it's going to shake out. So anyway, so this is, again, this is still 3x squared. You write it down. This is going to be 3 times. This is going to be yeah. So this is 18x cubed, and 3 times 6. It almost worked out, but it doesn't work out. So this would be 18. Actually, there's no other term to multiply by, so it's just this. Okay. Then you bring this down. This is 48x squared, and so this would be plus 8x, and 8x times 6x is 48 squared. We'll subtract it, and we get nothing, 52x. And what makes, oh, I guess it maybe would have worked. I just have to go to decimal land. But 6, I probably should have stuck with the other one. Whatever, you can always second guess, right? So here we go, 52 divided by 6 is 8 2/3. So that doesn't work out very pretty, but we roll with it, right? Let's see. So it'll be, it goes in 8 times then, full 8 times. And we're just going to get some mess left over, and that's okay. So 8 times 6x is 48x. And we subtract, and we get 4x. And bring down the 12. And this is kind of like the remainder. It's what's left over when you divide this. So it's this with this remainder, or if you want to write the remainder as a fraction, it'd be 4x plus 12 over 6x, like this. So this is probably a good way to express it, and that's why the answer key does it too. So, all right, find the value of z. Couldn't be easier. 3 and 6. So 3 squared plus 6 squared equals z squared. And this would be 9 plus 36 equals z squared. This is 45 equals z squared. And take the square root. This is square root of 45. Oh, here comes the crazies. Let's see if I can get this one done here. So a 9 would pop out. So, or a 9 times 5. And so it's 3 rad 5 when you clean that up. Oops. So hopefully that worked for you. All right, 2 more. Let me see if I can fly through, or if I'm going to be rudely interrupted by these wild crazies that are coming in here. Determine whether these are solutions of the system of linear inequalities. This is kind of easy. Just plug them into both and see if they're true. So just put this one in here, and this one I guess doesn't have a y value, so put this one there, and so right away you can tell the first one will not be, because one is no, that one's cool. So they're all good for the first equation, but then you plug it in there. This is gonna be a no here, and it's a yes here because you plug those in, and it does work. So inequalities, does that work? I'm debating whether 0, 0 does work. So 0 is bigger than that one, but 0 plus 0 is less than 0. That does not work there. That one doesn't make sense. So I think 0, 0 is not a solution. What about 5, 4? Is 5, 4 a solution? Let's try one out here and just make sure we're not crazy. Negative 25. And yeah, so that's cool. Negative 1. Let's see, 5 times negative 5. It's negative 25. And 3 times 4, that's 12. And that's less than 0. So that works for this one. And the x value is less than, is greater than or equal to 3. So I think they got these backwards in the answer key. So I'm going to say this is yes for this one and no for this one, because that's a no there. Let's check this other one. This is no, yeah, that's positive. So yeah, so I got no, yes, no for that one. Looks like the answer key might have made a mistake, or I'm crazy. Either way. Plot your data, just put a line on there. Once you do it, your line should roughly look like y equals 3 over 2x plus 5. You just kind of sketch a line through your data. You get some points on either side, and you're good to go. Somewhere in that ballpark. Anyway, good luck.